Okay, we're live again this morning. You'll probably see the infinite recursion of windows on the display right now as I'm sharing my desktop. Still haven't found a really good way of handling that particular issue. Now, for the people who are joining us by watching the video stream rather than actually joining into the Google Hangout session, just keep in mind that you'll see the broadcast from the beginning, even if you're time delayed. So if you start at 9:05 and we started broadcasting at 9 o'clock, when you ask a question, I won't seem to see the question in the video for about 5 minutes. If you ask a question close to the end of the session, it may not actually ever appear during the session on my display. All right, so let's go ahead and get going. All right, so the goal this morning is to discuss basic image processing and how to use some of the graphical interface. So I've got a directory here which we've used in past cryo-EM workshops, which has a variety of different file types present in it. Let's start with just the regular GUI tools. Now, if you're running E2 Project Manager, then
where is everybody?
So we're broadcasting.
Oh.
So if you're running E2 Project Manager, then we'll see the display that we saw in the previous demonstration. You probably don't want to run E2 Project Manager if you're not in an actual project directory. It tends to make other subdirectories in the directory. So if you just want to display image files, browse, that sort of thing, you don't need to do it. But let's take a look at how you do it from that interface if you're running it. So if you look at the Project Manager window, you'll see there's a button that's shaped sort of like a folder up here. Yes, we probably need to improve the icons. You see as I mouse over, it says Browse button. If we click on that, that'll open up a file browser window. And that's the main interface that you'll use if you're looking at images interactively. There are other buttons over here which we didn't really talk about last time. I think we looked at the Task Manager, which shows you jobs that are running in the current session. There are also a couple of other buttons in here. Some of them work, some of them don't do anything useful just yet. This is still somewhat a work in progress. So I'm going to exit the Project Manager, and we're just going to go back to the display. Now, of course, that shouldn't have happened. We'll just ignore that. That's probably because this directory is set to be read-only. At least that's a possibility. Anyway, let's just go ahead and use E2 Display. So if you run E2 Display without any options, it will just open up a display window like this. Now, again, I apologize that the font is kind of small. It may be difficult to read. But we should be able to see that there's a list of files present on the screen. Actually, let me see if I can just adjust the display resolution here a little bit and see how that messes up the session. I'm going to stop my screen sharing for a moment, and then I'll turn it back on again as soon as I let's see. Well, at least I think I'm going to stop. Oh. Sorry, this is a bit of a learning experience for me as well. No, stop broadcast will stop the entire thing from going. Let's see. Well, maybe I'll try doing it without stopping the screen share. Hopefully this won't just mess up the entire session. Ah, I see. All right. All right. So hopefully this will be a little bit more readable now. maybe I'll just go back and tell it that I'm going to start screen sharing again, and maybe that will use the new display. Okay, we're sharing the screen again. And let me open the question and answer widget so we can see any questions people submit. All right, so no questions yet. That's good. Okay, so I had opened up the E2 display without any options. And that opens the window like this and shows me the list of files in the current directory, and we can see a little bit different information than we'd see if we used the system file browser. So, if I just open the Finder in this current directory, let's see, data, and I think I'm in the workshop EMAN2 sample images directory. All right, so now if we look at what we would see in the normal file system file browser, obviously there's a bunch of fields that aren't present there. So the browser here will tell you the dimensions of images if it's an image file. It'll tell you the number of images in the file if it's an image file, date, and other sort of standard fields. Let's just click on one of these images and see what we can find out. Now there's a button up here that says Info. The Info button will give you information about the file, but doesn't let you visualize the file itself. So if I open up the Info window, and then I select a file, just by single-clicking on it, not double-clicking, we'll see that it'll show me all of the header information for that particular image file. If I select, this is an MRC volume, and you can see here that we have all of these MRC header items. So if you're interested in seeing the contents of the image header from any of these different file formats, this is a good way of accomplishing it. If I click on, for example, the spider stack, we'll see that there are spider header values. If I click on an Imagic stack, I'll see, well, it's a stack, so I'll have to pick one of the images, but we'll see the Imagic header values. If the file format is MRC, there is only one header for the entire MRC file, and the concept of putting particle data, multiple 2D images into an MRC file is kind of an abuse of the file format. So if I look at an MRC stack file, I may see a bunch of different images, but the header is going to be exactly the same for all of them because there's simply no space for different header parameters in there. Let's see, what else can we do with this here? Now you'll notice over here there's some buttons that have appeared at the bottom of the display, and they're similar to the buttons that I see at the bottom of my main window display. So when I select an image stack file, and then I select an individual image within that file, I'll see the same thing over here that I see over here if it were a single image file. So here, if I look at a single image file, you'll see I have the same options that I saw over here when I had picked the single image. So that is, it allows me to do things with individual images from the file rather than do things with the entire stack of images, which is what the buttons over here would do. Let me just check for any questions. All right, looks like a couple of the people are probably having trouble logging into the session. It's all right. You'll still be able to watch it later on. So we'll get all of these kinks worked out as we continue doing these things in future weeks. Okay. So let's take a look at the contents of one of these files. So I have a couple of different options down here. There's Show Stack, which will let me see the entire stack of images in one window. Just like all of the other graphical interface windows in EMAN2, if I use the middle mouse button on the window, it will show a control panel. And the control panel will be context sensitive. It depends on what's being displayed in the window. That will determine what you see in the control panel. Now, on some machines, for example, let's say you're using a Mac, you don't have a mouse attached to it, you won't have a middle mouse button to press. There is a utility that you can download, free utility for the Mac called Middle Click, which actually allows you to turn a 3-finger tap into a middle mouse click. That's one way of dealing with it. The other way is if you hold down, let me see, I think it's the Command, no, not Command, Alt. Alt, yes. If you hold down the Alt button and you do a left click, that will have the same effect, and it will open up the control panel window. All right. So the things that I see when I'm looking at a multi-image display, I can see magnification, which lets me zoom in and zoom out. Now, sometimes you may find that you see absolutely nothing at all in the display. If you see nothing at all in the display in a multi-window display, probably that means that you scaled up so far or that the image is so large it doesn't fit on the screen. Now you see when I try to drag this higher, it won't let me go any further, but let's say my window was smaller, like that, you can see that the image disappears. The image window needs to be big enough to fit at least one image in it in this multi-image display for it to work properly. So if you don't see anything, try decreasing the magnification, which you can do with the magnification slider or with the mouse wheel. Okay, so the mouse wheel doesn't scroll up and down. If you want to scroll up and down, then you have to drag this scroll bar on the right. Okay, we can adjust the brightness and contrast. People may have noticed that when you adjust the brightness and contrast, the minimum and maximum values also change. That's because these are pairs, brightness and contrast, or minimum and maximum. If I adjust the minimum and maximum, it'll adjust the brightness and contrast as well. But you'll note when I adjust the maximum, it doesn't adjust the minimum, and when I adjust the contrast, it doesn't adjust the brightness, and so forth. So these are pairs. If I modify these two, it'll automatically modify these two, and vice versa, because it's a single transformation. There's also a gamma adjustment, which allows you to compensate for the gamma of your display. In the lower left-hand corner, we'll see this number. This is just the image number within the file, but I can also display any other header values that may be present to the images by bringing up this display here. So since this is an Imagic file, I could display, for example, any of the Imagic header values that are present, or I can display any of the standard values like the standard deviation of the image. Now these images have been normalized, so the standard deviation of all the images is basically 1, or very close to 1. So it's not very exciting in this case, but you get the basic idea. Okay, I can use the Save button, which will allow me to save the images in the window. Now, if I haven't done anything to the images in the window, obviously saving them again isn't exceptionally useful, other than I could change file formats. So, for example, this is an Imagic file. If I want to save it in the HDF format, I could say x.hdf, and it would create a new file. And if I go back to the file browser and refresh the display, we'll see I now have x.hdf, and it should have exactly the same properties as this Imagic file that we were looking at. Now you'll notice for the Imagic file that there are two files which appear to be the same. There's an imagic.hed and an imagic.img. This is a peculiarity of this Imagic file format. Specifically, Imagic files are actually pairs of two files. The headers and the image data are split into two separate files in the file system. If you want to deal with those files in EMAN2, you can access either one of the file names and it will have exactly the same effect. If you use both of the files, then it will treat it as if you've done the operation twice, because they're really the same file. All right, let's see. The delete button, I did mention this last time, I'll say it again, allows you to mark images for deletion. It only does this in memory. It's not modifying the file at all when I click on these images. But if I now press the Save button, which I'm not going to do again, it will exclude those images when it's saving the images to disk. Now, if I hit the Save button and I select the same file name, an existing file name, this x.hdf file, and say OK, x.hdf, it will ask me whether I want to overwrite the file or add the images to the end of the file. I won't actually do it. All right, now let me close this window, and let's see, we'll display one of these other image files. Oh no, this is a single image file. That's right. Let's look at a stack file. And you'll notice when I double-click on this other stack file, I still see these deleted images. It's displaying the images in the same window. So if I switch from one image file to another, it's just the contents of the image file were the same, so it didn't seem to change. Let's see. Oh, actually, no, it wasn't the same. All right, so here's a stack file. If I double-click on this file, we'll see different images. Right, there we go. But they're appearing in the same window. So when you double-click on an image in this window, the operation it performs whatever button is in the upper left corner for that type of image file. So this is the Show Stack. You'll note there's also a Show Stack Plus button. The Show Stack Plus button will open whatever the image is in a new window instead of the old window. Okay, and now if I open any other image files, if I open any other image files, it'll open in the new window instead of the original window. So if you want to have multiple windows of a particular type open at one time, then you use one of the plus buttons instead of just the regular button, instead of the non-plus button. All right. Now we'll see we have the Show Stack button. We also have the Show 2D button. So Show 2D shows an image in a single image view instead of a multi-image view. And the control panel for Show 2D is much more powerful than the control panel for the tile view window. So let's go ahead and do Show 2D in a slightly larger image. And I'll go ahead and open the control panel for that. And I'll zoom out a little bit so we can see the whole thing. Okay, so you can see there are a bunch of tabs over here. The tabs give you more powerful operations that you can modify the image, measure things in the image, that sort of thing. So for example, if I go to the Probe tab, I can measure the mean pixel values inside a box, and I can specify the size of the box. So by default, it's 32 by 32. Maybe a little hard to see that yellow box, but it's giving me average values inside there. If I want to measure distances, which will also let me measure values a little bit, I go to this Measure tab, and then that will allow me to measure distances between things in the images. And it will measure the distances both in pixels and in angstroms based on the angstrom per pixel value that you specify here. And it doesn't set that automatically for you based on the image. You have to actually provide the angstrom per pixel value that you like. The draw mode allows you to actually modify the contents of the image. This is useful for doing demonstrations and that sort of thing. If you watch the Fourier transform demo that I do, I explain how you can use that. Again, it doesn't modify the image on disk, it just modifies the image in memory. So if I draw on this image a little bit, and this is just a very simple drawing capability, and then I open the image again, you can see the drawing annotations I made went away. And then finally, we have the Python tab, which lets you type one-line Python commands, and you can both modify the image and examine parameters of the image. Now, a couple of other useful things that are available over here. There's the auto contrast button, which will adjust the contrast to have the histogram basically fill the display window. There's the invert button, which allows you to make black, white, white, black, etc., just for display purposes. Again, it doesn't modify the image data. Then this is actually pretty useful. This is a histogram normalization tool, and it allows you to sort of automatically optimize the contrast for the display. So if I say hist Gauss here, it will make the histogram of the image that we're looking at a Gaussian distribution, a normal distribution. Now in this case, you'll notice it didn't really do anything because the image that we're looking at already basically has a normal distribution. But in some cases, if you're looking at whole micrographs, this will actually improve the visible contrast quite a bit, and it'll save you from having to tweak the brightness and contrast a lot when you move from one image to another. Hist flat will make the histogram flat to the best extent that it can, and will just optimize the contrast in a somewhat different way. Now, if we want to look at Fourier transforms, which can be useful, looking at the 2D power spectrum of an image, you can press the AMP button to look at the 2D Fourier transform amplitudes. Now, you'll note we'll have to hit auto contrast after doing that to get things reasonable for the display. So there's the Fourier transform of the image, the amplitudes of the transform. I can look at the phases. If we look at the phases, again, we'll have to normalize again. The phases are displayed in black and white. So they go from 0 to 2 pi, and then they wrap back around again. So that can create some odd visual artifacts. Again, if you look at the Fourier transform demo that I did, you'll see a little bit more about that. So an alternative strategy, if you hit the FFT button, is it will display the amplitudes as intensity on the screen, and it will display the phases as color. And since color is cyclic, red, green, blue, you don't have any discontinuities when it reaches sort of the edge of the phase space, because there is no edge. All right, so that's about it for 2D display. Let's take a look at a 3D volume. Now you see when I select a 3D volume, I have more options available. Now I have Show 3D, which is the default. I still have my Show Stack and Show 2D options available. So if I show my, well, let's start with 3D, then we'll go back. Okay, so now if I use the mouse wheel in the 3D volume, it zooms in and out. And again, if I open the control panel, you can see now I get a much more fully functional control panel displayed here. Hang on, I'm going to pop back really quick and see if there are any questions. Okay, we have a few more viewers now, but no one submitted any questions yet. That's fine. All right. So in EMAN 2.0, the display window only let you look at one 3D volume at a time, which was kind of limiting in a lot of contexts. The new 3D display widget lets you look at multiple 3D objects at a time. It allows you to do annotations and that sort of thing. We're not trying to replace a full-featured tool like Chimera. In fact, you can see there's a button down here for launching Chimera. But we are trying to provide some convenience features which are useful when you're trying to look at the results of, say, a reconstruction. So let me actually go ahead and exit this, and I'm going to go to one of the refinement directories, maybe the refinement that we did last week. Let's see. So we'll go into the refinement directory, and we'll look at the results. There was only one iteration there. Let's take a look at this one. Okay, so we had several 3D refinements, several iterations successfully complete. So the first one is 3D01, so I'm going to say Show 3D Plus to open that in a new window, and then I'm going to double-click on 2, 3, and 4. So that opens all 4 of those 3D models in the same display window, and now they're all sitting on top of each other in the same color. So you'd say, well, that's not very useful. You probably should change the color at least or something, right? Well, this can actually be useful. Once you've got them open, you can grab this slider down here, and you can cycle through them one at a time. And this gives you a nice way of following the convergence process as you go through multiple iterations of refinement. Okay, so I can slide this back and forth. Now, if you want to display 2 of them at the same time, for example, we can still do that. I can turn on and off. By right-clicking on this little eye icon, I can turn on and off specific displays. Oh. Unfortunately, it doesn't update the little eye icons when you grab this slider here, but what it's doing is turning them on and off. Okay, so now I've got 2 displayed at the same time. I can select ISO surface, look at the basic properties, and then, for example, I could adjust the color properties of that ISO surface. Hang on, let's see. Okay, there's not much ambient light present in this image. That's why it's looking more blue. Let's try diffuse. Hang on, why am I not? Huh. Something is not working as expected. Somehow I'm still not getting any updates in the display. Huh. All right, I'm not sure exactly why that is suddenly not working. It was working fine yesterday. All right, so we can adjust the isosurface threshold. That's working fine. Lighting parameters, camera parameters, background color. Huh, very strange. Well, you should be able to adjust the color here. We'll take a look at that later today and make sure it's working again. That should just adjust the color of that particular isosurface. All right. What else can we do with this display? We can also insert annotations in the display. For example, if I click on this line tool, I can drag line objects into the display and move them around with, say, the left mouse button. And these are actually 3D annotations. They're not 2D objects sitting on the surface of the display. They're actually 3-dimensional objects. So if I rotate the display around, and the checkbox determines what you're operating on when you're displaying. Oops, sorry, I'm still in draw line mode. Let's put this back in rotate mode. Now you can see I'm just rotating this one object because that is the only object I have selected over here. If I select everything again, now I can rotate it. We can see the annotations are actually in 3D. It takes a little bit of getting used to, but it does allow you to quickly make some annotations and modify your figures nicely for presentation. Again, if we want to use sort of a full-featured display tool, then we would probably use Chimera, which is pretty much the standard in the cryo-EM field, although I think I may not have it set up on my computer. Yeah, I don't have the Chimera button set up properly on this machine. It's installed from source. It's not one of the binary installs. Okay. So let's get back to some demos that actually work the way they're supposed to. Let's take a look at an image stack here. You can see I double-clicked on it. Again, I can just look at it this way. Let's say I want to do something to these images, like low-pass filter them or something like that. Well, we'll start by looking at how to do all of these things from the graphical interface. Then we'll go back and take a look at how to do them from the command line. So I'm going to use this interactive tool called Filter Tool to do that process. So I click Filter Tool, and again, I get a window which just contains the images. Now, this window won't actually contain all of the images unless the file is relatively small. If there's like 10,000 images, it's not going to display all 10,000. It will only display a fraction of them. Now, I've got another window that's hidden here that actually opened up at the same time. There it is. Okay, so we'll see two windows appear. We'll see this window appear with the images, and we'll see this window appear which has these funny buttons in it, but no other real content. And this word default at the top. What this allows you to do is construct chains of image processing tools. So if we look on the left button here, we'll see there's a category. Okay, so the filters or image processing tools are subdivided into various categories. For example, in this case, I want to do a filter, so I'll start with filter, and then the right button will contain all of these specific types of filters that are available within that category. So we can see here we've got, for example, a low-pass Gaussian filter. And once I select a specific filter, I'll get a set of options, sliders that I can grab. So in this case, there are a variety of different ways I can specify the cutoff for the filter. I can specify in absolute terms. If I mouse over that element, you can see this is the processor radius in terms of Nyquist frequency. So this is basically saying the value needs to be between 0 and 0.5. And 0.5 would represent Nyquist frequency, which is the highest possible frequency. Now you see when I grab the slider, nothing happens. That's because I have the entire filter disabled here with this checkbox. Very often you'll need to set the parameters before you have something valid for processing the image, so it starts disabled, and you have to enable it once you've got a value set that you're happy with. So we'll go ahead and say the angstrom per pixel value is 2.1. It's not actually necessary with this particular way of specifying the cutoff, but we'll need it for the others. And then I'll enable the filter, and you should have seen that it got blurrier all of a sudden. And if I grab it out this way, it'll get less blurry. If I drag it in this way, it'll get blurrier and blurrier and blurrier. Okay? So a low-pass filter at Nyquist frequency has pretty much no effect. It has a little bit of effect since it's a Gaussian filter. So it's saying the half width is at Nyquist frequency. So it is getting rid of a little bit of high-resolution information, but not very much. And as I get to lower and lower spatial frequencies, it makes things blurrier and blurrier. Now, instead of specifying with an absolute cutoff, maybe I want to specify it in terms of angstroms. So if I check the cutoff frequency box, this will be specified in terms of reciprocal angstroms based on the angstrom per pixel value provided here. So here, now if I grab the slider, so if I say 0.1 here, I can actually just type in the box, it'll be filtering this image to 10 angstrom resolution, basically. If I say 0.04, it'll be filtering it to about 25 angstrom resolution, that sort of thing. Now keep in mind that the filters are relative. If I filter this to 25 angstroms and then I followed it with another Gaussian filter to 25 angstroms, then those two filters would combine with each other and it would be even more filtered than that. So you can't say, unless you're starting with a perfect infinite resolution image, you can't just say I'm going to low pass filter to this resolution and say that that means that I have that resolution. In other words, if I start with an image that's already 25 angstroms and then I filter it to 25 angstroms with a filter like this, it's going to filter it some more. And what you'll be left with is the sum of the squares. It's the RMS, the sort of the root mean squared average of the resolutions, at least if you're using Gaussian filters. So let's actually try that. I can do 2 filters in a row. So if I press this little plus button, I'll get another empty pair of boxes, and I can say filter low pass Gauss here as well. And I haven't turned it on yet again, so let's turn it off here, and we'll turn it on here, and we'll set the absolute cutoff to 0.1. And then down here, we'll also set the absolute cutoff to 0.1, and when I turn it on, you can see it gets even blurrier. Okay, so that's one low pass, so that's unfiltered, one low pass filter to 0.1, and 2 low pass filters to 0.1. Now I could do something different here. I don't have to do a low pass, I could do a high pass filter. That might be more useful. So let's say high pass Gaussian. Now I have a combination of a low pass filter and a high pass filter. Now, since this is okay, this is basically a band pass filter, so I'm now basically only leaving behind stuff between roughly 0.073 and 0.164. Now, what if I give them the same value? Since it's a Gaussian filter, I don't get rid of everything, right? I'm still left with this sort of peak of information centered at, oops, sorry, that's supposed to be 0.1, peak of information centered around 0.1. But if I was doing something instead, like this was a, let's see, sharp filter, let's see, low pass, top hat, that's what we have it called. A top hat filter is a sharp cutoff at that frequency. So in other words, it's 1 until the value you specify, and then it's 0. So if I set both of these to be a top hat filter, oops, high pass top hat, now I've basically filtered out everything in the image. All I'm left with is some high resolution noise, which for some reason hasn't been set to 0. It's probably just a tiny, tiny value that's residual in the floating point curve. Now if I lower this a little bit, you'll see I'll get some of the image information actually coming back in. But unless I get the low pass, the high pass frequency low enough, I'm not going to really see much in the image. Right? You can see it emerging again now, but if I'm really getting rid of all the low resolution information, then there's just nothing really left to see in the image. All right, so this allows you to construct sequences of filters and other sorts of operations, and they're not all filters. There are things like masks, for example. So if I want to apply a soft circular mask, I can specify, I left it enabled here, so it's already on. I can specify, let's see, an outer radius for the mask. Now, you'll notice that the default value for this slider here is maximum value is 5. So the biggest I could make the mask seems to be 5. However, I can type larger values in there. If I say type 20, it'll make the mask value 20, and then the slider maximum will also expand to that range. But that's not always convenient. What if now I wanted the maximum to be back to 5 again? How would I reduce the range? Well, these sliders, these value sliders as they're called, are set up so you can actually specify greater than, less than values in the box. So if I say less than 5 here, it will readjust the, it'll readjust the maximum of the slider, so the maximum value will be 5 again. If I say less than 200, now I can actually adjust the mask out to fairly high radii. So I can interactively play with my mask parameters. I can specify the width as well, because it's a soft mask. If we zoom in here, we can see that if I do this, it's a very sharp edge, and if I do this, it gets softer. So this is a 5-pixel width now of the edge. And that's explained if I mouse over it. Okay, these would, for example, allow me to change the center position of the mask, so it's not centered in the middle anymore. I have to shift it maybe a little bit more to really see it. And that can be useful in certain contexts. Now you'll notice there's a dx, a dy, and a dz. This particular operation can also be applied to 3-dimensional volume data, not just 2-dimensional data. So that's why the dz is present there. All right. Now, once I've finished setting up, let's say I've done this for all of, I've set up the parameters in such a way that I like them, and I want to apply those parameters to a bunch of images. Now, if I want to apply them to these images, this particular stack file I'm looking at, I can go up to the File menu and I can say Save Processed Stack, and that will apply the current set of filters I have to the stack and save it with a new file name. Alternatively, if I exit the filter tool and go back to the command line prompt here, we'll see that there's a new file present in the directory which is called filtertool default.txt. Now we can actually use our file browser, sorry, not this file browser, we'll use E2 display, and we can actually look at that text file that way as well. So if I go to filtertool.txt and I hit the info button, I can see the text file, and actually I can use this as a little text editor if I want. If I hit the edit button, it'll allow me to modify the contents of the file. But you can see the contents of this text file. It has a little descriptive stuff at the front. The pound sign is a comment line, so we can put whatever we want after it. This file contains the parameters of the processor set named default. And you remember it had that default box at the top of the screen. That was the name we gave this particular set of processors. If I had made a processor set with a different name, then it would have saved it under a different file name here, and that way we can have multiple sequences of processors. If we look down here, we'll see this line without a comment. Process filter low pass top hat cutoff absolute equals and a value. And then below here, process mask.soft, dx, dy, dz, etc., and then all of these options. If I want to use the same sequence of processors in the command line, these give me what I need to know to do it. So I'm going to go ahead and highlight this and copy it, and I'm going to highlight this and I'm going to copy it. Now I have a little tool set up on my Mac, so I can actually have multiple things in the clipboard at the same time. You could do it sequentially though instead. All right. The generic image processing commands in EMAN2 are E2proc2D and E2proc3D. One is obviously for volume data, and the other is obviously for 2D data. So let's say I want to apply that exact sequence of processors to a set of 2D images. I can say e2proc2d.py, then let's process, for example, the spider stack. Spider stack, and then I give it an output file name. We'll call it y.hdf. And then we just need to put those process options in there. So we'll put in the first process option, which was the filter, and then we'll put in the second process option, which was the mask. Okay, so we put those in exactly in the same way we saw them in that file. -- process equals, and then the name of the processor, followed by colon, parameter equals value, and optionally there may be more parameters, so I can say mask.soft, dx equals colon, dy equals colon, etc., so I can separate them with colons. If I do that, it will process the entire stack of images and generate an output file. And if I say E2 display on y.hdf, we will see there are the images that have been filtered and masked. Okay, now E2proc2D and E2proc3D can do a lot more than just these basic image processing operations. So let's get into that a little bit. So if we type e2proc2d.py help -- help, it will give us all of the available options for the command. Okay, so there's a fair number of different options. I can do things like specify angst per pixel value. I could average all of the images in the file. I could compute a structure factor, that is, compute the Fourier transform of all of the images, turn that into a one-dimensional curve, and then average that one-dimensional curve over all of the images. I can resize the images. I can include and exclude various ranges. So if I have a text file that has a list of image numbers that I want to exclude from the output file, I can specify exclude. There's just all sorts of different specific options in here. Now, e2proc2d.py is designed to deal with stacks of particles. So by default, if you give it a file name that has multiple files in it as an input, it will process all of the images in that file. If you want to change that behavior, the first and last options allow you to specify the first image you want to operate on and the last image you want to operate on in the file. Now, the other thing about proc2d is that its default behavior is to append images to the end of an output file. This gives you a mechanism where you can construct a large file from a bunch of smaller input files. So, for example, if I said e2proc2d.py x.hdf z.hdf, it'll copy the 272 images to the output file without changing it in any way. So if I just say proc2d input output, it will just copy the images. And if I do the same operation again, now you'll see I have twice as many images in the file. It's made a copy of the image data. So if I look at this output file, we'll see that image number 0, the first image, is going to be the same as image number 278, I think. 272, sorry, 272. Okay? Now, if you don't want to do that, if your goal is to process the images in, so you say you want to apply a low-pass filter and you decide the parameters weren't quite right and you want to do it again, you don't want to add the new filtered images to the end of the file, then there's an option which allows you to turn off that behavior. So let's remove z.hdf. And I'm going to go ahead and do that again. I'll do the e2proc2d. So I've now copied the images without modification of the file. Now let's say, oh, oops, I forgot. I wanted to invert the contrast in the file. So if I did that again and I said --mult equals -1, multiply all the pixel values by -1, it would append the images to the end. So I'd have the uninverted copy followed by the inverted copy. The option in place allows you to modify that, and it will force it to write the output images to the same position they have in the input images. So now if we look at the file, you can see, oops, the contrast has been inverted in all of the images, the output images. Okay, there are a bunch of other options in here. We don't really have time to go through all of them. I'll see if anyone's asked any questions. Okay, no questions still. Okay, there's a bunch of options. We're not going to have time to go through all of them. Let me see if there's any other really important ones. All right. Yeah, all right. There are a couple of things we should look at. If you're interested in rescaling your images, there are a couple of different ways of rescaling the images. One of them is to use the scale option in combination with the clip option. Okay, the scale option will rescale the data in the images, but it won't resize the boxes the images are in. Okay, the clip option will resize the box, but it won't change the size of the data. It won't rescale the data. So let's try both of those separately. So we'll do another e2proc2d, and this time we'll say scale equals 2. And then we'll make a different file, zz.hdf, where we've said clip equals, I don't remember what the image size was. That's fine, we'll just make it small, like 32 by 32. Now if we look at those two output files, we'll see that z, oops. Oh, sorry, I didn't use the in place option. So the scaled images are at the end of the file, which is what I warned you about before. So there's the ones that have been rescaled and not inverted. So you can see now how the end view is completely filling the box, whereas before it was just in the very center of the box. So it's been scaled up by a factor of 2, but the box size is the same. If I look at zz.hdf, you'll see that the images have been clipped, so now we're just looking at the very center of those Breuil particles that we were looking at before, where it's just black in the middle. So it just chopped off the edges of the images. So if we want to rescale images, we need to combine those operations if we want to sort of properly rescale them. The reason they're separate operations is because you need to be careful about the box size that you're using when you're doing single particle processing. Normally when you're doing single particle processing, you only want to use a so-called good box size. Let me open a window, and we'll go to the EMAN2 wiki. Oops. And there's this section in here, mathematical conventions, image processing functions, and in here we'll see box size. And this has a list of good box sizes to use when you're doing image processing. The various algorithms that EMAN uses for various purposes, Fourier transforms being one of them, will have different efficiencies depending on the size of the box associated with it. So, for example, if I did a single particle reconstruction with a box size of 64, it would take a certain amount of time. If I used a box size of 65, it would take dramatically longer, not just a little bit longer. This page details all of that, and it actually shows you how the relative speed of every possible box size from 0 to 512. That can be shown in different ways. You can look at it as a text file if you like, but the bottom line is you should always use one of these box sizes if possible. If you use a box size outside this list, then your refinement would actually run faster if you made the box bigger to the next size that was in the list. In other words, if I had a box size of 85, it would actually run faster if I used a box size of 100 than it would with a box size of 85, despite the fact that it's more data to process. Okay, so we should always round up to a number that's present in this list. All right, so if I want to scale my data in some fashion, say I need to correct for a magnification error when the microscope was calibrated or something like that, so I just need to do a little scaling operation, I would do something like z.hd. Let me remove my z files. X.hdf, I would do something like z.hdf dash scale equals 1.05, for example, and dash clip. So what's my box size? All right. Now let's say I want to find out information about the image, but I don't want to open the browser again. There's a command called e2iminfo.py, which will give you basic information about the file. So if I say x.hdf, it will tell me the dimensions of the particles, 100 by 100, how many images are in the file, and there are actually other options in there, for example, dash all, which will give me information about all of the images in the file, and things like dash stat, which will give me statistical information about all the images in the file, or I could say dash header, and it will give me all of the header information from a specified image in the file. If I said dash header dash all, it would do it, but then I'd have massive pages of output files. All right, let's get back to our E2proc2D. Let's see. Let's go back. So let's say I need to rescale my spider stack file. Okay, then I need to combine that with a clip to make the box size bigger as well. Let's see, clip equals 110 by 110. Okay, so that makes the box size also 5% bigger. Now there's a problem with this. Let's see what we got. If we look at our output file, you'll notice that around the edge of each image is a gray area. So what happened is I first made the image bigger, and then I made the box that it was going into bigger. Okay, so when it made the box bigger, it just filled it in with 0 values. It didn't actually copy the image value. So it basically scaled the image and threw away a bunch of stuff at the edge, right, because the image got bigger, and then it made the box bigger and just filled it in with gray values. So if I want to scale an image up, I need to invert the order of those operations and put the scale second. Now, again, you can see I didn't use in place. but that's what we want in this case. Okay, so you can see the images at the beginning, which were done the old way, and now the images at the end, which were done the new way, and still have a tiny edge. Oh, sorry. The images were only 100. I made the box too big. It should have been 105, not 110. Yeah, so I still had a little 5-pixel border there. Now, if I were downscaling the images, so I was scaling to, say, 0.95, then I should do it in the other order, right? Otherwise, I would clip stuff off the edge, and then it would shrink it, and then I would again have an edge of stuff at the end. Now, normally, if you're rescaling images, if you're rescaling by a large factor, like a factor of 2 or a factor of 3 to make the image processing faster when you're working with downsampled, low-resolution data, there's a special set of options for that. One of them, the main one you'll probably use, is -- mean shrink. And what this does is it just does a little local average. So if I say mean shrink equals 2, it will make the box size smaller by a factor of 2, and it will downscale the data by a factor of 2, but it does it, instead of by just sampling the data, it does it by averaging 2 by 2 boxes in the image. So it doesn't throw any information away. Now, if you talk to Powell about this, he will point out that, of course, you should also low-pass filter your data if you plan to do this. Otherwise, you will get something called Fourier aliasing, which will put the high-resolution noise back into your image at the end of the power spectrum. Normally, this isn't a very big effect because of the rapid fall off in the power spectrum, but it isn't a bad idea to go ahead and low-pass filter the data. There's a processor that's available which can also do this by actually just truncating the data in Fourier space. If that doesn't mean very much to you, don't worry about it too much. For the purposes, most people will be shrinking their data by 2, which is just initial data processing to get a low-resolution structure of stuff. Just doing mean shrink equals 2 is absolutely fine. You're probably going to go back and process the original unshrunken data later anyway, so it's just really not worth worrying about too much. Okay, pretty much all of the options I was just talking about also exist for a command called e2proc3d. And you'll note I said just -h here. That's an alternative. Instead of saying --help, I could also say -h. It'll give me the same help information. So if we look here, we'll see a very similar set of options, but it's targeting 3-dimensional data instead of 2-dimensional data. Let me just go back and double check. Oh, hang on, let's see. Scale option in EMAN1 and let me select the question, sorry. Okay, so Dongwad asked this question. The scale option in EMAN1 and EMAN2 is doing the opposite way correct. No. In EMAN1, when you specified options in Proc2D, it picked what order the operations would go in. So if you were making the image bigger, it would do it in the right order, and if you're making them smaller, it would do it in the right order. But that also means that you couldn't do sequences of commands. So if I want to do, say, 3 processor commands in a row, in EMAN1 there was no way to do it. You could only do one thing at a time per command. In EMAN2, it obeys the order of operations that you give it. So it's not quite the opposite way. It's just obeys the order of operations, or not order of operations. It does them in the order you specify. Let's see. Kushal asked a question. Let's deal with that one. I knew how to iterate over BDB images in that typical format and apply some Proc2D. Now there is no BDB. What would be the substitute for BDB? The default image format in EMAN2.1 is HDF. So all image files by default will go into HDF in EMAN2.1, and all metadata by default that isn't in the image header goes into JSON files, which those also used to be in the BDB interface. The nice advantage to that is they're all flat files. So you can just move them around. You can do whatever you want with them. You can use them on shared file systems. Although you could, still run into problems. If you're using a shared file system and you have 2 different computers both outputting to the same HDF file at the same time, you could still cause file corruption and other problems like that. So you have to be a little bit careful, but you're not going to have these issues with corrupting the BDB, corrupting the database, and having to try and recover it and that sort of thing anymore. So hopefully that covers the question. Feel free to ask a follow-up if that didn't answer. Okay, we're down to about another 5 or 10 minutes here, so let's see what else we can cover. So a lot of the options here are exactly the same. The same things I was telling you about before when you were rescaling a 3D volume, you needed to do the same sort of thing you were doing when we were talking before. There are a number of additional options in Proc 3D that didn't exist in Proc 2D, like Sim for imposing symmetry on a map. There is the, let's see, most of these options are the same. Type a line. Yeah, there's some options for doing 3D alignments. This is just single-step 3D alignments. If you want to do real multi-stage alignments between two 3D volumes and stuff, then we have a bunch of single-particle tomography tools for doing that, and some other separate command line programs for doing that kind of thing. There are also some options here specifically for icosahedral particles. There are different conventions for the orientation of an icosahedral particle. A lot of software produces things in the so-called 2-2-2 convention, where the X, Y, and Z axes all have twofold symmetries on them. EMAN uses the fivefold convention, where the Z-axis has a fivefold symmetry on it instead. These allow you to rotate between those two conventions easily. One other important thing, the default in Proc 2D is to append images to the end of the file. Technically, you can also have stacks of 3D volumes. The HDF file format supports that very nicely, and we use that for single particle tomography a lot now. But the default behavior for Proc 3D is to overwrite output files. So the default for Proc 3D is to write the images in place. So it's the equivalent of the in place option in Proc 2D. If you want to append images to the end of the file in Proc 3D, you have to specify the append option. And this is mostly sort of an artifact because of the common usage patterns. When you're doing Proc 2D, very often appending is what you want to do most frequently. And when you're doing Proc 3D, normally you're just overwriting the output files over and over again. So that's the reason they're different. Let's see, any other really important options here? All right. Now, you'll notice that process option that I used to do the image processing seems to be sort of hidden in here. I mean, it's present in here, process, and it tells you how to use it, but it doesn't tell you what all of the various processors you could use are. So how would you find them out? Other than using filter tool to look at them, to pick them interactively, how would you find out the available processors? So this isn't just for processors. There's lots of places in EMAN where there are multiple different algorithms you could use for a particular task, like comparing images, image similarity between two volumes, two images. Those use similarity metrics. So there's a command called e2help. e2help.py. You can also look on the web, of course. It's available via the wiki, but this is more convenient in most cases. So if you say e2help.py, it'll give you a list of the categories of modular classes, as we call them, which are available. So processors are things that you'd use with the --process option in Proc 2D or Proc 3D. So if I say e2help.py processors, it will give me a list of all of the processors. And you can see there's a pretty long list. There's, I don't know, over 100 of them. 182 of them. Okay? You can see they are categorized, and they're categorized in the same way that we saw in filter tool. So if I just want to see, for example, the filter processors, I can say processors filter, and that will only show me things that have filter in them. Okay. Now, it doesn't give you a lot of detail here. It gives you the name of the processor, and it gives you the parameters that the processor takes along with the type of data associated with that parameter, but it doesn't give you much detailed help. So how would I know what a low-pass Gaussian filter is if I don't know what Gauss means? So there's another option, which is common to most EMAN2 programs, which is verbose, which the shortcut for is V. If I say V1 or V2, the number doesn't matter in this particular case. It will give me more information. So now, again, I'm seeing the list of all of the processors, and this will wrap in a better way if you have a wider display. I'm displaying this with a large font so people can see it, so it's getting cut off a little bit. We can see that filter.lowpass.gauss is a low-pass Gauss filter processor applied in Fourier space. Well, the English isn't terrific, but other than that, it at least tells you what's going on, and it will explain what the various parameters are. Now, in a lot of the filter processors, as I said before, you have an option of 4 different ways, or at least 3 different ways of specifying the parameter. You can either specify it in terms of Nyquist frequency, you can specify it in terms of the resolution, which is 1 over the spatial frequency, or you can specify it in terms of pixels in Fourier space. So it'll give you the range for each of these various choices. One reason why you might want to do it in absolute values is if you're trying to process an image that isn't square. If you have a rectangular image and you say give it Fourier pixels, which is how we did things in EMAN1, then the cutoff frequency would be different in the 2 directions, right? Because 50 Fourier pixels in, say, the x direction would be different than 50 Fourier pixels in the y direction if the image were rectangular. If you do it in terms of absolute cutoff instead, then you'd say I want to go to half Nyquist, for example, and half Nyquist would still be half Nyquist in both directions.
What exactly is a Fourier pixel?
It's a pixel in the Fourier transform of the image. So if you have a 128 by 128 image in real space, you do a Fourier transform, you'll have a 130 by 128 image in Fourier space. The extra 2 pixels are because of just the way the Fourier transform is handled. It's not quite in place. That's probably too long a discussion for right now. But basically, you'll end up with an image that's the same size in Fourier space. So a Fourier pixel is just 1 pixel in that space. So in other words, if you wanted to specify Nyquist frequency and the image size were 128 by 128, 64 would be Nyquist. Let's see. Okay, no more follow-up questions. So technically we're at 10 o'clock. I'll go for a few more minutes here just to sort of wrap things up a little bit. Let's see. So that's how we find out about processors. If you need, for example, to find out about similarity metrics, which you might use as extra options for the E2 refine easy command, we might say e2help.py cmp -v2, and that'll list all of the image similarity metrics. Now you can see there's some funny wrapping going on here. We'll do without the verbose mode, and we'll see it a little bit better. So we can see there's cross-correlation coefficient, dot product, which is basically the same as cross-correlation coefficient, Fourier ring correlation, phase, mean phase error, square Euclidean distance. So there are various similarity metrics. And there are other things that we can get help about as well. For example, when we make averages, there's a CTF correcting averager, and there's a non-CTF correcting averager. When we make 3D projections, there are various ways that we can accomplish that sort of thing. Let's see. Symmetries is probably a useful one. That's a little different than the others. But if you want to know the list of supported symmetries, that'll tell you. So we basically support all of the biological symmetries. CD, H is for helical symmetry, icosahedral. Icosahedral, I think that ICOS2 must be icosahedral with the 222 convention, then octahedral and tetrahedral. You'll notice there are, of course, other symmetry groups that exist, but all biological objects have handedness. So any of these symmetry groups that have a mirror symmetry present in them, have a mirror operation present in them, aren't valid for a biological contest. So this should represent all of the available symmetries that you might run into. Let's see. What else? Let's just take a quick look and make sure we didn't skip anything in the graphical interface. Oh, there is one thing we skipped, which is probably useful. Let me go back to a project directory. The one thing we didn't look at was plotting. So there, if you have a text file, if I do info, you can actually see the contents of the text file. So if I have a text file which just consists of rows of numbers, you might generate with a spreadsheet or something like that, I'll have the option for plot 2D, plot 2D plus, which will display it in a XY plot window. And if I open the control panel, I'll get some control over these options. I could say put it on a log scale, for example. Let's see, the left mouse button gives me crosshairs and lets me look at locations in the image. And you'll notice that conveniently it will tell you both the spatial frequency as well as 1 over the spatial frequency in parentheses. So that's nice for trying to look at resolutions in these plots. And then if I use the right mouse button, dragging with the right mouse button will let me zoom in, and just clicking without dragging will let me rescale out. There's some limited capabilities for annotations and that sort of thing here, but if you want to really make sort of nice figures and stuff, you probably want to use a real plotting program. This is, again, mostly just a convenience feature. Let's see, anything else? So if you have a text file, again, that doesn't appear to contain numeric data, then the only way of doing anything with it is with this info button, where it'll let you look at it and potentially edit it. Let's see. All right, I think we've covered most of the image types. Oh, one last thing I forgot to do when we were looking at 3D volumes. Let me just get back to that really quick. So let's say we have a 3D volume. I showed you how to scroll through multiple volumes and do something and annotate them a little bit, and strangely not change the color. I wonder if the color will work right if I'm just displaying one of them. Huh. Looks like recently somehow the color must have just broken completely. All right, let's forget the color again for now. Let's say I want to display a slice through my structure, or if I want to do, let's say I want to do volume rendering. Those options also exist here. So what I need to do is I need to select the data set. So not the isosurface. The isosurface is where I would change the isosurface threshold and stuff. But I select the actual data set, which the isosurface is a member of. And then I have to hit this Add Object button. And look here, and you'll see there's Slice, Isosurface, and Volume. So let me add a slice, and I'll just say Add Node. And now you see I'll get a slice, which by default will start in the orientation where you're just looking straight at it on the screen. Now you can see there's a slice through my data. If I rotate to a different orientation, I could do it again, Add Object, Slice, and now I have 2 slices intersecting in space, and I could turn off my isosurface, and now I can see my 2 intersecting slices. If I select one of those, I could rotate it independent of the other ones. I could use the basic properties to move it around in space and slice through the volume in various ways. So this lets me do slices, which can be very useful in some contexts. There's also volume visualization. I just say volume, add node, and it will add a volume rendering. Oops, sorry, I got the wrong one selected. It'll add a volume rendering to the middle of the display. Turn off the slices so we just see the volume rendering, and we might want to might have to play with the options a little bit. Huh. I think that's related to the color problem. Oh, sorry, I don't have it selected. There we go. So here's the curve for selecting the options for volume rendering. Oh, no, they are broken. Brightness is working, but the level selector is broken. So something funny is going on with colors. We're going to have to take a look at that before we do the Beta 3 release today, I think. Anyway, so here now we can see a pretty reasonable volume rendering. I don't think I would try and use this for like a 4K by 4K by 1K tomogram or something like that. But for looking at 3D structures, it's fun. Okay. All right. So we've run basically out of time. Let me see if there were any last questions. No. Okay. So if people have any other questions, we'll be doing another one of these a week from now, and there'll be another opportunity to look at stuff. I think. Let me just see. Yeah. So I'll think about over the next week exactly what I'm going to talk about in the next week topic. If you have any suggestions for things that you'd like me to talk about next week, please feel free to make them. The week after that is going to be the Gordon conference, so I won't be doing one the following week. Thanks for joining.